Today, I'm going to continue the discussion on circles. So we're going to have the following exercises. Number 1, determine analytically if the point is inside, outside, or on the circle x squared plus y squared minus 2x plus 4y minus 5 equal to 0. So letter A, 1, negative 1. Letter B, 4, 5. And letter C, 2, 1. So to determine if each of these points is inside, outside, or on the circle, we're going to get the distance of each of these points from the center of the circle. If the distance is less than the radius, it is inside the circle. If the distance is equal to the radius, then it is on the circle. Okay? Considering the given equation of the circle, so this is the equation of the circle, x squared plus y squared minus 2x plus 4y minus 5 equal to 0. So let us reduce this to standard form. So getting x squared minus 2x plus 1. So this is now a perfect square trinomial. Then we have y squared plus 4y, then plus 4. Add positive 5 on each side. We have 5 on the right side. And then also we need to add 1 and 4 because we added on the left 1 and 4. So on the right, we have to add 1 and 4 also. Okay? This gives us x minus 1, quantity squared plus y plus 2, quantity squared. This is equal to 10. Therefore, we have center 1, negative 2. And the radius is square root of 10. For letter A, the point is 1, negative 1. Let's call it P. So, and we want to get the distance of P1 from the center. P1 going to center. That is square root of 1 minus 1, quantity squared, plus negative 2 minus negative 1, quantity squared. Okay? And this is equal to 1. 1 is less than square root of 10. Therefore, the point 1, 1. Therefore, the point 1, negative 1 is inside the circle. Okay, what about letter B? Let's call this P2, 4, 5, the coordinates. Let's get the distance of P2 from the center. Getting square root of 1 minus 4, quantity squared, plus negative 2 minus 5, quantity squared. This is equal to, the radical is 9 plus 49, so that is 58. So square root of 58 is the distance. And this is greater than square root of 10. Hence, we say that the point 4, 5 is where? Outside the circle. Okay? Any question with that? Okay, what about letter C? Let's call it P3, and the point is 2, 1. Getting the distance of P3 from the center, we have square root of 1 minus 2, quantity squared, plus negative 2 minus 1, quantity squared, and this is equal to square root of, so the radicand is 1 plus 9, so it's square root of 10. And this is equal to the radius. Okay? So we say that the point 2, 1 is what? Is on the circle. Get it, guys? Okay, so let's have number 2. Find the points of intersection of the given curves. For letter A, we have x squared plus y squared equals 5. So this is circle. And 2x plus 3y equals 7. And this is straight line. To get the intersections of this circle and line, so we have to solve them simultaneously. For letter A, x squared plus y squared equals 5. Let's call it equation number 1. Then we have 2x plus 3y equals 7. And this is equation number 2. Okay? So let's consider first equation number 2 and then solve for either x or y. Solving for y, we have 7 minus 2x all over 3. So this is our y. Okay? So let's call this equation number 3. So let's substitute this y of equation number 3 to the y of 1. So from equation number 1, we have x squared plus y, but what is our y? 7 minus 2x all over 3, quantity squared. And this is equal to 5. Multiplying both sides by 9, we have 9x squared plus 9 here is canceled out with 9 here. So getting, after expanding the numerator, we get 49 minus 28x and then plus 4x squared. And that is equal to 45. Okay? Simplifying the left side, we have 13x squared, then minus 28x plus 4. And this is equal to 0. Okay, guys? So let's see if this is factorable. We have 13x minus 4x minus 1. Possible? So it's not, no? We have 13x minus 2 x minus 2 equal to 0. Is that right? So let's check. 13x squared, negative 2x, negative 26, that is negative 28x, and then positive 4. equating its factor to 0. So for the first linear equation, we have 13x minus 2. So what is x? 2 over 13. While in the second linear equation, we have x equals 2. If x equals 2 over 13, what is y? So that is 7 minus 2 times 2 over 13 all over 3. So we solve y from equation number 3. Simplifying this by multiplying 13, both the numerator and denominator. So we have 7 times 13. What is that? 91. Then minus 4. 13 is canceled out. All over 39. Okay? So y therefore is equal to 91 minus 4. So that is 87 over 39. So the simplified form is 29 over 13. Hence, one of the points of intersection of this line and this circle is at 2 over 13, 29 over 13. What about the second possible point of intersection? If x equals 2, what is y? So that is 7 minus 2 times 2 all over 3. Simplifying, we have 3 over 3, and that is equal to 1. Therefore, the second possible point of intersection, we have 2, 1. So there are 2 points of intersection between this line and the given circle. So meaning when you draw the graph of this circle and the graph of this line, they will intersect at these points. Okay? What about the second one? For letter B, we have the following equations. Let's call this equation 1. And let's call this equation 2. This is line and this is circle. Okay? From equation 1, we have y equals 2x minus 2. Substitute these two, equation number 2. So we have x squared plus y squared. But what is y? 2x minus 2. Quantity squared minus 2x, then plus 4y. Y is 2x minus 2. Then minus 3 equal to 0. So let's simplify by expanding this binomial and then distributing this 4 inside parentheses. So getting 4x squared minus 8x plus 4. Okay? What about here? Minus 2x, then plus 8x minus 8. Minus 3 equals 0. getting 5x squared. Then this is eliminated. What about the constants? 4 minus 8, that is negative 4 minus 3. So that is negative 7, no? Negative 7 equals 0. Okay? Am I right? So let's check. X squared plus 4x squared minus 8x plus 4 minus 2x, and then plus 4 times 2x, that is, so there is still negative 2x. Hence, we get 5x squared, then minus 2x minus 7 equals 0. Okay? So let's try if this is factorable, this left side. We have 5x minus, let's try 7 here, and then x plus 1. And this is equal to 0. Okay? Let's check. 5x squared minus 7x plus 5x is negative 2x, then negative 7. Okay. So let's equate its factor to 0. 5x minus 7 equal to 0, or x plus 1 is equal to 0. So for the first linear equation, we have x equals 7 over 5. For the second, we have x equals negative 1. Okay? If x is 7 over 5, what is y? So let's have from equation number 1, getting 7 times 2 over 5. So 2 times 7 over 5, then minus 2. Y therefore is equal to 14 divided by 5 minus 2, and that is 4 over 5. So hence, we have this point of intersection, 7 over 5, 4 over 5. Get it, guys? So this is one of the points of intersection. Let's see the other point of intersection. If x equals negative 1, what is y? We have 2 times negative 1 minus 2. Y therefore is equal to negative 4. Therefore, the second point of intersection of this line and the circle, we have negative 1, negative 4. Get it, guys? Let us have letter C. For letter C, we have the following curves, and the two curves are both circles. Okay, so let's call this equation 1, and this one equation 2. Now, to solve for x and y, let's eliminate the quadratic terms by getting the difference. 0, x squared minus x squared, that is 0. Y squared minus y squared, that is 0. 0 minus 4y, that is negative 4y. Then we have 0 plus 14. 0 minus negative 14, that is 0 plus 14. And this is equal to 10. Okay? Hence, for y negative, it is equal to negative 4. Y therefore is equal to what? 1. Okay, guys? So, if y is 1, what is x? So we can solve it from either equation 1 or equation 2. So let us have it from equation number 1. From equation number 1, we have x squared plus y squared. But what is y? 1. Square it, and that is equal to 10. Okay? X squared, therefore, is equal to 9. And hence, we have x is equal to plus or minus 3. Therefore, there are 2 points of intersection, and these are, first, we have 3, 1, and then the second one, negative 3, positive 1. Okay, guys? So these are the 2 points of intersection of the 2 circles. Okay, any question with that? So let us have problem number 3. The circle x squared plus y squared minus 4x plus 6y equals n passes through 2, negative 1. Find the value of n, the radius, and the center. Since this 2, negative 1 is a point on the circle, it must satisfy the equation of the circle. So let's substitute 2, negative 1 to x and y respectively. We're given this equation of the circle, x squared plus y squared minus 4x plus 6y, and this is equal to n. At the point 2, negative 1, we get 2 squared plus negative 1, quantity squared, minus 4 times 2, plus 6 times negative 1, and this is equal to n. N therefore is equal to 4 plus 1 minus 8 minus 6, and that is equal to negative 9. Therefore, the equation of the circle is x squared plus y squared minus 4x plus 6y equals negative 9, where n is equal to what? Negative 9. Okay? So to get the radius, we can reduce this to what? To center radius form, separating x terms from the y terms. We get x squared minus 4x plus y squared plus 6y equals negative 9. Okay? By completing the square in each group, we add half the coefficient of x, that is negative 2, square it. For the second group, to make it perfect square trinomial, we add half the coefficient of y, that is 3, square it, 9. Since we added 4 and 9 on its since we added 4 and 9 on the left side, we have to add 4 and 9 also on the right side. Okay? Getting x minus 2 quantity squared plus y plus 3 quantity squared, and this is equal to 4. Therefore, what's the radius? The radius is equal to 4, and the center is given by 2, negative 3. Okay? Let's have number 4. For what values of a and b will x squared plus y squared plus 8 will x squared plus y squared plus ax plus by plus 8 equal to 0 be the equation of a circle having the center for negative 1? Find the radius of this circle. From the equation of the circle, we have x squared plus y squared plus ax plus by plus 8 is equal to 0. Let us reduce this to center radius form. Let us get the center of this. Remember our formula. If you do not want to reduce this to center radius form, so we say that h is equal to negative 1/2 of the coefficient of x. So that is a. Okay? But we're given the center and its h is given by 4. Therefore, a is equal to 8, negative 8. Therefore, a is equal to negative 8. Okay? So this is the value of a. What about k? K is equal to negative 1/2 the coefficient of y, and that is b. So we have negative 1/2 b. Since we're given the center and its y coordinate or the k is negative 1, so we say that b is equal to 2. Okay? So these are the values of a and b respectively, negative 8 and positive 2. What about the radius of the circle? The equation of the circle is given by x squared plus y squared plus a. But what is a? Negative 8 times x, then plus b, but is b, 2 times y, then plus 8 is equal to 0. Okay? Now, to get the radius, we can use the formula 1/2 square root of our d here is negative 8. So negative 8 quantity squared plus e, that is 2, square it, then plus f times 4, and then minus 4 times f. But what is f? We have 8. Okay, guys? So let's simplify this. 64 plus 4 minus 4 times 8. We have 36. Square root of that is 6. Divide by 2. So we have 3. So the radius of this circle is 3. Okay? That's it. Any question with this? Okay, so let's proceed to number 5. Determine the values of k or value of k so that the line determine the value or values of k so that the graph of x squared plus y squared plus 2x minus 4y equals k squared minus 4k plus 10 all over k minus 2 is a circle, is a point, and letter C is an empty set. So let's start with letter A. For letter A, we want this to be what? To be a circle, meaning when you draw the graph, it is a circle. So what is the value of k or values of k? Okay. Now for this to be a circle, now the right side for this to be circle, let us first reduce this to center radius form, getting x squared plus y squared plus 2x minus 4y equals, so this is the given, k squared minus 4k plus 10 all over k minus 2. Then, completing the square by what? Then, let us group the x terms separately from the y terms. And then add 1 to make it perfect square trinomial. What about the y terms? Y squared minus 4y, then plus 4. So let's add also on the right side 1 and 4. So that is equal to 5, no? Actually, k squared minus 4k plus 10 all over k minus 2, then plus what? Plus 5, okay? Now, for this to be a circle, this right side must be what? Greater than 0, okay? So, and this is actually r squared. So our r squared is equal to k squared minus 4k plus 10 all over k minus 2 and then plus 5. This is equal to, when simplified, we have k squared minus 4k plus 10 plus 5k minus 10 all over k minus 2. Simplifying, we have r squared equals the numerator is k squared plus k all over k minus 2. Okay? Now, for this to be circle, this must be greater than 0. Solving this inequality, this rational inequality, we have k plus 1, factor the numerator, then the denominator is k minus 2 greater than 0. Okay? Now using sign chart, we have number line for k. Now here, what are the critical numbers? For the critical numbers, in the numerator, we have 0, -1. In the denominator, 2. Okay? So let us arrange these critical numbers on a number line. We have here -1, 0, and then 2. Okay? List down the factors. We have k in the numerator, in the denominator. In the numerator, list down the factors in the numerator, and then in the denominator. In the numerator, we have k plus 1. In the denominator, k minus 2. So let's determine the sign. To the left of -1, so this k is what? K is 0 here. K plus 1 is 0 when k is -1. K minus 2 is 0 when k is 2. To the right of 0, k is positive. To the left, negative. To the right of -1, k plus 1 is positive. And then to the left, negative. So remember, solving rational inequality in your Gen Math. So to the left of 2, this is negative, this k minus 2. And then to the right, positive. Okay? Now let's take the signs. Negative, negative, negative. So that is negative. Negative, positive, negative. That is positive. We're getting the product, then quotient of this product and k minus 2. No? Positive, positive, numerator over negative. That is negative. Positive, positive, positive. This is positive. We want it to be greater than 0. Therefore, we have this interval. Okay, guys? So hence, this is circle if what? If k is in the interval -1 to 0, open interval, union with greater than 2 to positive infinity. Okay? So this is the answer for letter A. So again, any value of k in this interval will make this equation of this circle, this equation, for any k in this interval, this equation will represent a circle. Okay? What about letter B, a point? Now, when will this be a point? Now, for this to be a point, this right side, this is already the simplest form, no, of r squared, must be equal to what? 0. So let's just copy that. For letter B, the equation will represent a point if this value of k squared plus k all over k minus 2 is equal to 0. Okay? So for this to be 0, we have k squared plus k is equal to 0, multiplying by k minus 2. Factoring out k, we have k plus 1 equal to 0. Equating its factor to 0, we have k equals 0 or k is equal to -1. Therefore, this equation represents a point if k is element of this set. 0, -1 as the elements. Okay, meaning k is either 0 or -1. Okay? What about letter C? For letter C, r squared, which is equal to k squared plus k. This is the simplified form of the r squared. K squared plus k all over k minus 2. This is the equation represents an empty set if this is less than 0. Okay? Now, for this to be less than 0, all we have to do is to consider this solution in letter A. Okay? So let's get this sign chart. The only difference is that instead of positive, we want it to be what? Negative, the quotient. Okay? So this is what we want this time. Hence, k is an element of this interval, -infinity to less than -1, union with between 0 and 2. Any value of k that is in this interval will make the given equation an empty set. Clear? Oh, that's it. This time, let's talk about circles determined by 3 geometric conditions. How to write equations of circles given 3 geometric conditions. If the given conditions are 3 non-collinear points, of a circle or on a circle, use any of these equations. We have x squared plus y squared plus dx plus ey plus f is equal to 0. Okay? Our goal is to form 3 equations that will lead us to the values of d, e, and f. Okay. The other one, we have the standard form, x minus h quantity squared plus y minus k quantity squared equals r squared. Otherwise, use the standard form. And of course, other related equations. Okay, let us have the following examples. Write the equation of the circle satisfying the given conditions. Number one, we have passing through -1, 2, 3, 4, and 2, -1. Since we're given 3 points, we can use either the general form or the standard form. So let us first use the general form. Let's illustrate the problem. Consider this Cartesian plane. Plotting the given points, we have -1, 2, three, 4. So it's somewhere here. 2, -1. Let's try to fit the circle that will pass through these points. Okay, so this is the possible circle passing through those given points. So this is 3, 4. This point is 2, -1. And this one, we have -1, +2. We need to form 3 equations using x squared plus y squared plus dx plus ey plus f equal to 0 at -1, 2. We have -1 squared plus 2 squared minus 1d plus 2e plus f equals 0. Okay? Simplifying, we get -d plus 2e plus f is equal to -5. So this is our first equation. Okay? What about the second equation? At 3, 4, we have 3 squared plus 4 squared plus 3d plus 4e plus f is equal to 0. Simplifying, we have 3d plus 4e plus f is equal to 9 plus 16, that is 25. Adding negative 25 on each side, we have negative 25 on the right side. Okay, guys? So this is equation number 2. At the third point, we have 2, negative 1. Substituting this to the x and y of the general form of the circle, we have 2 squared plus negative 1 quantity squared plus 2d minus e plus f is equal to 0. Okay? Simplifying, we have 2d minus e, then plus f is equal to negative 5. This is equation number 3. Let us solve these 3 equations. This first, second, and third simultaneously. From equation number 1 and 2, this is the first equation. The second equation is this equation. Okay? So let us eliminate f by getting the difference between these 2 equations. Negative d minus 3d, that is negative 4d. 2e minus 4e, that is negative 2e. F minus f, that is equal to 0. Negative 5 minus negative 25, that is positive 20. Okay? Dividing by 2, we get negative 2d minus e is equal to 10. Okay, so let's have this equation number 4. From equations 1 and 3, again, eliminate f. Our first equation is negative d plus 2e plus f equals negative 5. Our second equation, we have, our third equation, we have 2d minus e plus f is equal to negative 5. Okay? Getting the difference, we have negative 3d plus 3e, this is 0, equals 0. Dividing by 3, we have negative d plus e is equal to 0. Let's call this equation number 5. Okay? Solving equations 4 and 5, we have equation 4 plus equation 5. Addition. Negative 2d plus negative d, that is negative 3d. Negative e plus e 0, and that is equal to 10. Okay? So hence, d equals negative 10 over 3. Let's mark this. What about e? So we can solve it from either 4 or 5. Let's have it from 5. From equation number 5, we have negative of negative 10 over 3, then plus e is equal to 0. Therefore, e is equal to negative 10 over 3. What about f? F can be solved from either 1, 2, or 3. Let us have it from equation number 3. From equation number 3, we have 2 times negative 10 over 3 minus negative 10 over 3, then plus f is equal to negative 5. F therefore is equal to negative 5 plus 20 divided by 3 minus 10 divided by 2. So that is equal to negative 5 over 3. Therefore, the equation of the circle is given by x squared plus y squared minus 10 over 3x plus negative 10 over 3y minus 5 over 3 equal to 0. Or multiplying by 3 each side, we get 3x squared plus 3y squared minus 10x minus 10y minus 5 equal to 0. Okay? So this is the equation of the circle. What about if we use the standard form? So we have solution 2. Using the standard form, x minus h quantity squared plus y minus k quantity squared is equal to r squared. At the first point, we have negative 1, 2. Substitute these two, x and y respectively, these coordinates, getting negative 1 minus h quantity squared plus 2 minus k quantity squared equals r squared. Expanding this left side, we get h squared plus k squared minus of positive, then double 2h, then minus 4k, constant terms 1 here, 4, so total of 5. So plus 5 equals r squared. So this is our equation number 1. At the second point, 3, 4, we have 3 minus h quantity squared plus 4 minus k quantity squared equals r squared. Expansion of the left side gives us h squared plus k squared minus 6h minus 8k, 9 plus 16, that is 25, equals r squared. So this is equation number 2. At the last point, 2, negative 1. We have 2 minus h quantity squared plus negative 1 minus k quantity squared equals r squared. Expanding the left side, getting h squared plus k squared minus 4h plus 2k. What about the constant terms? 4, then 1, so total of 5 equals r squared. Okay, so that's equation number 3. Let's solve these 3 equations simultaneously, beginning with this first combination, 1 and 2, and then getting the difference to eliminate the quadratic terms. H squared minus h squared, 0, k squared minus k squared, 0. This right side, r squared minus r squared, 0. So leaving 2 minus negative 6, so that is 8 multiplied by h. What about for the k? Negative 4 plus 8, so positive 4. Then multiplied by k. Constant, 5 minus 25, so minus 20 equals 0. Dividing by 4, we get 2h plus k minus 5 equal to 0. So this serves as our equation number 4. What about another combination, 2 and 3? Getting again the difference to eliminate the quadratics. So leaving only negative 6h minus negative 4h, that is negative 2h. Then negative 8k minus 2k, that is negative 10k. 25 minus 5, positive 20, equal to 0. Now, since this is numerically equal with the coefficient of h in the fourth equation, we're not going to simplify this anymore. Leave it as is. Solving 4 and 5 simultaneously, eliminating h by addition, 2h plus negative 2h, 0. K plus negative 10k, that is negative 9k. What about the constants? Negative 5 plus 20. So giving 15. On the left side, on the right side, negative 15. So k therefore is equal to 5 over 3. Okay, guys? What about h? h times 2 plus k. K is 5 over 3. So this is from equation number 4. And this is minus 5 equal to 0. Multiply by 3 to get 6h plus 5 minus 15 is equal to 0. Simplifying, we get 6h is equal to, this is 10, right? So h therefore is 5 over 3, right? Let us have r squared. What about r squared? From equation number 1, we have 1 minus h, negative, no? Negative 1 minus 5 over 3, quantity squared, then plus 2 minus k, k is 5 over 3, quantity squared, equals r squared. R squared therefore is equal to 64 over 9, and then plus 1 over 9, getting 65 over 9. Okay, guys? Therefore, the equation of the circle in center radius form is given by x minus 5 over 3 quantity squared plus y minus 5 over 3 quantity squared, and that is equal to 65 over 9. That's it. If this is expanded and expressed in general form, we will have 3x squared plus 3y squared minus 10x minus 10y minus 5 is equal to 0. Okay? Get it, guys? You can verify it by expanding and then simplifying, expressing all the terms on the left side.